Okay, here we are starting the physics for you for the ninth standard, and here you are going to learn a very important and interesting subject, that is physics. And the important thing here is, when you are learning physics, just keep in mind, this is not the subject what you are going to do just by hearting or by just following the rote methods like just mugging up or practicing it number of times. This is not the way. Just understanding and thinking about it. Understanding and thinking about it. Okay? Remember this. Whenever I just say something to you, you try to understand that. And after that you think of it. Then you will get a good relation with the subject. And certainly you will be just enjoying this subject. Okay? Right. So here in your ninth standard, we are having few chapters in your ninth standard, and all the chapters in the ninth standard are very important and they are basic for your physics. And already you might have learned some topics in your 8th and 7th classes where you might have learned some basics. Here again, whenever we come across them, we just go with them, and these, whatever you are learning in the 9th class especially, those are useful for your higher education, wherever the physics is there. If you go to intermediate there, +1 or 11th class, they are completely, unless you understand these concepts, you can't do anything there. And if you can't do anything there, then you can't do anything in your competitive exams. And if you are not able to understand these concepts, if you just take any subject which is related to the physics, like engineering, then nothing will be there in your brain. So keeping all these things in the view, just whenever you are observing here in the video class, you just concentrate, understand, visualize, and think of it. Okay? And physics is a subject of visualizing the concepts. Visualizing, just imagining. Just if I say some force is exerted, you have to think that you are applying some force on a certain body. So this is the way how we go with the subject. Suppose if I say a man is lifting a weight, just you have to imagine a man is lifting the weight. A stone is thrown upwards, you have to imagine that you are just throwing a stone upwards. Then only you can, if you just imagine and involve in that, then you can understand the subject easily and perfectly. Okay? Alright. So now in this, we are going to start with the chapter motion. Motion means it is the movement. Already you know about this. Okay, now in this chapter here, first let us talk about rest and motion. So rest and motion. If I ask you what is rest, you say the bodies which are stationary. Up to your understanding, up to your level of understanding, you will be thinking like this. It is, the body is stationary, or if it is at a particular place, even if you observe for a certain time, it is at a particular place, then you will be saying the body is at rest. Then if I ask you what is motion, the body is just, you will understand like this. If it is here, if it is going like this, then it is having some motion, you will understand like this. Okay? Then how to, not only your understanding, you have to make the other person also understand, and you have to express your understanding with the words. So here, how to just understand this means, when the body is said to be at rest, if the body is not changing its position, that already we know. If the body is not changing its position, with respect to another body or with respect to time. So suppose let us take a body is at point A, and after 2 seconds the body is at A, after 3 seconds the body is at A, after 4 seconds, so body is remaining here. So with respect to time, so this is not changing its position, then we will be saying the body is at rest. Then just in opposite to this we can say, if it is changing its position, so if it is at A, now it is at B, and after some time it is at C, and after some time it is at D, now it is changing its position with respect to time, now we will be saying the body is in motion. So here certain things we have to talk about this, about the rest and motion. So here we know that in the universe, nobody is at rest. We can't find a body which is at rest. Universe itself is in motion, isn't it? So here how we can understand, how we can say it here means here, we say a body is in rest or in motion with respect to another body. For example, if you are moving in a bus, if you are sitting in moving in a bus and sitting in a seat along with your co-passenger, the bus is moving, and with respect to you, your co-passenger is at rest, isn't it? With respect to you, your co-passenger is at rest. Suppose if another person is standing outside the bus on the what do you call it as, maybe some not in this body, in this bus, somewhere outside. What he will observe? He will observe when this bus is moving, your co-passenger is moving with respect to that person. So with respect to you, he is at rest. With respect to the other person, he is in motion. So here, so by this we are saying here, rest and motion are not absolute. They are relative. So whenever you are talking about the rest or motion, you just say with respect to time or with respect to another body. Okay, right. When I talk about this motion, it is complex. Motion is complex. That means many types of motion we have. The body, if it is just moving like this, the body is moving in a straight line. It is rotatory motion. And if it is moving like this, oscillatory motion. Suppose if it is moving like this, vibratory motion. So many types of motions are there. Rotatory, oscillatory, vibratory, straight line motion. So in this chapter we deal with the straight line motion. Straight line motion. So the body is moving in a straight line. If it is moving in a straight line, it covers certain path, certain length of the path. So here the length, suppose if it is moving suppose if the body is starting from A, and if it is moving like this and reached B, now the total length from here, that means throughout along the path we have to measure, so like this. So this will be calling as the total length covered by the body is called as distance. The total length covered by the body is called as distance. And here one more word is there, which generally we will usually be using in the place of this distance. The meaning may be same, similarly it may be giving the same meaning, but physics the meaning is different. That is the displacement. What is this displacement? Displacement also is related to the body moving or changing whenever it changes its position. So here, from here to there, it has covered some length, but here it is giving a different meaning than the distance. So in this example, the body has moved from A to B like this. That means we have just measured the complete path like this, so total length covered. So now if you want to find the displacement, we have to draw a straight line from A to B, and this is your displacement. So what do we say, how can I define this displacement? Means here it is a straight line path from, this is your initial point or initial position, and this is your final position. Straight line path from initial position to the final position is displacement. Okay, so now we understood the two terms, that is distance and displacement. So now here let us go with one more example here. A. Now the body has moved up to here for 5 meters, and here the body has moved for latitudes of 4 meters, and that the body has moved to C for 3 meters. You understood the difference between the distance and displacement. Distance and displacement. From the distance you understood that it is the total length covered by the body, and the displacement, it is the straight line path from initial to final. From initial to final. Just understand like this. So in this example here, the body has started from A, moved to B, and then to C. So by that definition, you can easily say here, if I ask you what is the distance, what you will do from A to B, it is 4 meter, and from B to C, it is 3 meter. So total it is 7 meter. So the distance covered here is the 7 meter. And coming to the second one, displacement. Displacement. What is displacement? The straight line path from initial. So this is your initial and this is your final. So what is the straight line path here? Is this your straight line path? No. So the straight line path means this is your straight line path. So you have to measure the straight line path AC. Then that will give your answer. So look at this diagram given here. How it is looking like? It is a right angle triangle. Right angle triangle. So how to find the right angle triangle? Hypotenuse AC is equal to square root of AB square plus BC square. You know the Pythagorean theorem says that AC square is equal to AB square plus BC square. So from this we have extracted that root of AB square plus BC square. So it is root of 4 square, AB square 4 square, and BC square 3 square. So it is root of 16 plus 9, it is root of 25, so it is 5 meter. So it is 5 meter. Okay. So here, look at the body has moved from A to C. The same body has moved from A to C. It has actually moved A to B and then to C, and we found the distance. It is 7 meter. And we calculated the displacement, that is 5 meter. Are they same? No, they are not same. That means here, even though we are, up to now you just understood that you might have used the word for the same meaning, but from here onwards in physics they are the different words. So it is distance and displacement, they are different. So now you understood what is the distance. It is the total length covered by the body. So this is the total length covered by the body. And the displacement, it is the straight line path. So here what we observe here, it is the displacement is less than the distance, isn't it? Right. And one more thing here. Let's go with one more example. Suppose if the body is moving in a circular path. body is moving in a circular path. So it has started from A, and this is the center O, and having radius 7 meter. Now it made one revolution. It made one revolution. So now it made one revolution means it has started from A and finally ended at A. So its initial point is final point. Now if I ask you what is the distance, what is the distance here in this case? So you have to measure this one, isn't it? This we will be calling as the circumference. Circumference of the circle. Circumference of the circle. How to find the circumference of the circle? You know the formula, it is 2 pi r. So it is 2 pi is 7 into r, it is 7. So it is 44 meter. So now you got the distance as 44 meter. Now if I ask you what is the displacement? Displacement means immediately if you hear the word displacement, in your mind you have to only just come to 2 points. One is where is the initial point, where is the final point, and what is the straight line path between them. Understood? If I ask you what is, whenever you just see the displacement, just remember where is the initial point, where is the final point, and what is the straight line path between them. So here, in this case, initial point is final point. That means they are coinciding. So what is the length between this initial point and final point? It is 0. So it is 0. So in this example, we just understood that distance is having a value. Is having a value means having a magnitude. We will be calling here it as the magnitude in physics. And displacement is 0. So here we understood from this displacement is less than the distance. And here one more thing we have extracted here. Even though displacement is 0, we can have the distance. Displacement can be 0 and even we can have the distance. And we'll go one more thing here. Suppose if this is a straight line path, A, B. So this is, let it be of some x meter. So what is the distance in this case? It is 7 meter, the total length. What is the displacement in this case? It is 7 meter. So in this case, displacement, whenever I say displacement, initial point, final point. This is a straight line path. So it is x meter, x meter. So in this case, distance is equal to the displacement. So from this you might understand one more thing. Displacement can be 0 and displacement is always less than distance, and distance is equal to displacement. That means distance, we can give a relation between distance and displacement. It is distance will be greater than displacement, or it can be equal to the displacement. So distance will be greater than or equal to the displacement. Okay. So we understood it from these examples. Now let us talk about this distance and displacement. Some more points related with this distance and displacement. Distance is denoted by d. Distance is denoted by d, and displacement is denoted by s. So distance and displacement. So first one is, we can give the definition. So this is the total length covered by the body, and this is definition here is, it is the straight line path from initial point to the final point. So in this case, in this example you observe here, the body is moving initially in this direction and then it moved to the another direction. Suppose if in the earlier example we have taken like this. So here the body moved in this direction, in this direction, in this direction, and in this direction. That means no particular direction whenever we are talking about the distance. But when you are talking about displacement, displacement means what you will do? You will take the initial point and final point. So look here, this is the displacement. So it is moving in a particular direction. Coming to this example here, the body is moving in a circular path. So if you just take this point, where is the direction means? It will be in this direction. It is in this direction. It is in this direction. It is in this direction. So now, at each and every point, when it is moving in a circular path, the direction of the particle is changing. So now, the distance means it will not have any particular direction. Displacement, it will be having a particular direction. So, distance, it is a quantity which do not require direction to specify. That means only magnitude is enough. And this is a quantity which require direction to specify. Such type of quantities we are having a name. Already you might have learned in other classes, that is they are scalar. So distance is a scalar quantity and this is a vector quantity. So definition, this is one more difference. This is scalar and displacement is a vector. So because it is a vector, we can also represent by means of a bar. Whenever you see if F is there, it's a symbol of some physical quantity. And if you just see bar on this, that means it is a vector quantity. It is a vector quantity. Okay. So that's so because it is a vector quantity, I can put the bar here. Only if you don't put, that's no issue here, no problem. So that you can put a bar there. Now the units, distance is length and displacement is also length. So both are representing the length. So length, what are the units of length? What are the systems we have? We have I or MKS and CGS. These are the two systems what we follow. We don't go with the FPS. So in SI or MKS, what is the length? What is the unit of length? It is meter. In CGS, what is the unit of length? It is centimeter. Okay. So that is what you call it as the introduction regarding distance and displacement. And the next class will come up with the numericals.